Okay guys, this is going to be a video on how to use and make a binary tree. Now what you're going to need to know is how to use objects and how to use array lists. Now I said before, I gotta get this out of the way first, that you can never have two objects be equal to each other, and that's actually a complete lie. If you create an object, apple, and say equals apple 2, that forces this apple to be equal to this apple. Simple as that. That's how you make two objects equal. I'm not sure if you have to use that in this actually, but just know that for a fact. Okay, so what a binary tree is for, it's for sorting objects really quickly. So as soon as you input an object into a binary tree, it will go through the tree and be sorted. And you can use the binary tree to sort names or numbers or files or whatever. So here's what you do. You have to create a node first, a node class. Node class. Okay. And each node, let me draw this for you guys. Each node is going to be, let's say, right here. That's a node. It's going to have a left and a right. And you haven't learned about this value yet, but they can either be null values or they can be filled with another node. And so each one of these nodes has a left and a right, and that's if they are not null. If they're not null, they have a left and a right. And all these lefts and rights can be either null or they can also be nodes. And so you can see how this can very quickly get to be really big. For most binary trees, left is less than and right is greater than. The thing about binary trees is you can't have, well, you can't have two different objects that are equal. So if you add two objects that are the same or comparatively equal, it will not store two objects. It's only going to store one of them. It'll discard the other one. Okay. So Java has standard nodes, but we're actually going to be creating our own. Oh, and how the sorting works, I'll show you here first because it's rather important. I told you that this is less than this one, and that means that this one is greater than this one. So let's say we have a 10 here and a 2 here and a 40 here. Now let's say we add a 25. It's gonna go into the top of the tree, and you'll see, well, it figures out that 25 is bigger than 10, so it'll go down to 40 and check. Well, actually, if this node was empty, it would put it in there, but since we already have this node full, it goes down. It's trying to find a space. So we have 25. It's just floating around. It sees it's less than 40. So it goes down to this node. Oh, there's nothing there. So now we have 25. Now let's add 14. Well, 14, it is greater than 10, so it's going to go down here to 40. But it's less than 40, so it goes down to 25. And it's less than 25, so it's going to go down to 14. And we make another node here. Okay. Now let's add 8. So we see 8 goes into the tree. It's less than 10, so it figures out, oh, it needs to go here, or this node sends it here, but 8 is greater than 2, so the node 2 sends 8 to the right, and you end up with this node being equal to 8. And you can just see how after each number trickles down, it comes into an ordered location. And so, to be able to get a list of objects, you just ask for the list from the top node. So, from 10, it asks for the it'll get a list from 2, and then it'll add itself in the middle, and then it'll get a list from 40. So you'll end up with 2's list, and then 10, and then 40's list. Okay, and well, 2 does the exact same thing as 10. They're both nodes. So 2, it'll get a list. It'll get its left list and its right list. Well, there's nothing on the left. So the 2, it just puts itself first. And so it's the middle. Well, there's nothing on the left, so it's technically the left. And then it'll add its right list, which is only 8. 8 doesn't have anything, so it has 8. So there is our 2 list. Goes 2, 8, then 10 in the middle, and then the 40 list. So it gets its list on the left, which is 25. 25 adds its list on the left, which is 14. So 14, 25, 14, 25, and 40. It's very crappy handwriting, but I think you can make it out. So it goes 2, 8, 10, 14, 25, and 40. And you see, we didn't add any of these numbers in order, but it is all completely organized. Pretty cool.